Hey, my name is Ross Cagan. I am a professor here at Mount Sinai and also Associate Dean of the School of Biological Sciences. And let's see, my first purpose is to talk about what our lab does. And first let's start with my training. I was an undergraduate at University of Chicago, graduate school at Princeton where I got my PhD in neurobiology, postdoc at UCLA, and ran a lab at WashU Medical School in St. Louis for 14 years. At WashU, we primarily focused on eye development using Drosophila, and in fact, my lab still studies aspects of eye development in a small group in the laboratory. But a few years ago, we began to change our focus, and now the majority of the lab studies disease and diabetes. In fact, one of the reasons I came here to Mount Sinai was to take advantage of the skill set here in translational biology. Basically came here, flipped my lab over to focus on disease, and off we go. So I've been here 4.5 years. In cancer, my lab is creating multigenic models of cancer. For example, 3, 4, 5-hit models of colorectal cancer, breast cancer, lung cancer. And what we're able to show is that when you embrace the complexity of cancer, embrace the complexity of the sequencing data, which is how we build the flies, what we find is a lot of emergent properties. So we're doing a lot of network analysis. We also can show that in terms of sensitivity to drugs, a 1-hit animal is quite different than a 4-hit animal. And these are probably represent major reasons why drugs fail in clinical trials, because our models to date are too simple. And of course we're working to make more complex drugs, which takes me to the flip side of what we're doing. We also test drugs in flies. For example, we grow flies in a 96-well plate format, and we screen drug libraries, and we look for drugs that make the flies better, make tumors go away, make the diabetes recede. And we've developed a method with a medicinal chemist colleague of ours over at UCSF to use fly genetics and medicinal chemistry to generate more sophisticated drugs, where instead of generating a drug that hits a single target, we have been creating what we call rational polypharmacology, that is drugs that hit many targets but in a very rational stepwise fashion. And importantly, we leave certain targets alone that account for toxicity. So we think we can make new gen drugs that work better with lower toxicity. And we have a drug we're pushing towards phase 1, so time will tell. We also have diabetes models in the lab where we just feed the flies a high sugar diet. They get obese, hyperglycemic, hyperinsulinemic, all the good things that a card-carrying type 2 diabetic would get. And we've been focusing recently on diabetic cardiomyopathy, so their hearts fail in a way that looks something like what happens in people, and diabetic nephropathy, their kidneys fail, again, similar to what we see in people. We're looking at mechanism and also identifying drugs to make those all better. And then, of course, we have a project where we intersect the two. Why do diabetics get tumors that are more aggressive? And we've been identifying the mechanisms that do that too. So there's a fair bit going on in the lab, primarily looking at disease, also development. Now, switching gears, I can also say that a bit over a year ago, John Morrison kindly appointed me to be Associate Dean to serve in the graduate school, and that has been a ton of fun. I love hanging out with the students and trying to find ways to get them what they need. I really enjoy creating new courses and helping to restructure the graduate school to make it more user-friendly for the students, but also to push the students forward, really challenge them by thinking in new ways, for example, translational biology, which is near and dear to my heart. And it's been a lot of fun to work with the people in the graduate school, to get to know the students much better, and as an extra bonus, actually get to see sort of inner workings of Mount Sinai and how it works as well. So this has all been great. I really appreciated the opportunity to do that. And actually recording this now is a lot of fun for me because I'm told it will go up on my G Social, and that is also something that has been close and dear to my heart.
Why should a prospective student come to Mount Sinai?
A student should come to Mount Sinai because Mount Sinai represents what I would call 21st century science. So it's interesting to see now the people running Mount Sinai and the community in general really thinking hard and coming to grips with what a 21st century scientist look like. So what is the difference between a 21st and a 20th century scientist? There's many. One is most late 20th century scientists became PIs, principal investigators, and ran labs. That's not going to happen in the 21st century. Some will, but the majority will not. Also, translational science, which was always sort of given a tip of the hat, but academic science was really not particularly serious about it. Taxpayers have made the decision that they want us to focus more on translational science, which I actually find to be an interesting aspect anyway. That's going to change, where it's no longer we're going to do basic science that has some relevance to translational science, but we'll actually do translational science, where mechanism gives way to therapeutics. Mount Sinai does all of these very well. It is continuing to push the core structure forward, and even the structures of how you train forward in terms of thinking about connecting basic research in Mount Sinai laboratories to research with companies. This, I think, is really fantastic. It represents a great opportunity because Mount Sinai is both committed to it, and they are a, not small, but smaller institute that is very nimble. They can institute these changes rapidly. They're very metric driven, so they can decide whether our efforts are actually working, and then we just keep making it better. And to be honest, if I didn't think Mount Sinai was the best place to come to as a graduate student, I would change it until it was. So in my opinion, it is the best place. It's the most interesting place right now. There's a ton of new genomics, stem cell biology. The neurobiology here is fantastic. It's awesome. The sophistication in translational science, such as drug discovery and so on, is really becoming impressive. It's just an amazing place to be right now, and this is its moment. I would strongly recommend this place, and if I were looking for a graduate school right now, this is where I'd be.
And for those like yourself who would be coming, yourself, you came from St. Louis, transitioning to the New York lifestyle, what advice would you give to those students about New York and living in New York and what people say about New York?
So about New York and why New York is an amazing place. So I probably don't really have to sell New York, but I know a lot of people are worried about some aspects of New York, especially if you've had a conversation with your parents who remember New York from the 1970s, which I do since I grew up in New Jersey. At that time, there was a lot of crime. It was kind of a dirty place, and so on and so forth. That is old news. For those who aren't paying attention, New York is the safest city in America. The safest city in America. It is remarkably clean and at the same time retains the intensity and the fun and so on. It is an intense city. It is filled with energy, and sometimes when people come here, they get overwhelmed. I can just say that if you've been here a few months and then you go elsewhere, everywhere else seems boring. So if you're worried about how you're going to adapt to New York, just give it a little time, and almost everyone comes to love it. It also, there's something subtle about New York that I've really grown to appreciate, which is in New York you don't typically own a car. You get around by public transportation, which is really fantastic, or you walk, and there's a lot of walking. And in fact, New Yorkers live on average about a year longer than typical American because they're in better shape. But what that does is it breaks down that sort of mental barrier of talking to people. When you're in your car, you drive to work, you drive to the store, you hope nobody talks to you because you've basically forgotten how to talk to anybody anymore. You drive home and then you look up your friends. In New York, because you're moving through communities physically, you begin to learn how to just chit-chat with people. And, we're human beings. This is exactly what we should be doing. So New York really brings that back, and that is something I hadn't expected when we moved here, but I absolutely love it. And then, of course, there's a ton of stuff to do in New York. Probably nobody needs me to convince them of that. I'll just throw out one simple statistic, which is the number of restaurants in New York, which for some reason I looked up recently. There are 23,000 restaurants in New York. And in fact, with the natural turnover, you can eat breakfast, lunch, and dinner at a different place in New York for over 30 years without eating in the same place twice. That's just awesome.